We're first going to start off by explaining Azure RBAC so that we understand the authorization system inside of Azure. And then we're going to take a look at understanding role definitions so that we understand the components of a role definition. And then we're going to take a look at something known as additive properties so that we can understand evaluating role assignments to arrive to our effective permissions. And then we're going to get into a demonstration of assigning access to resources in a non-Azure Cloud sandbox. And then we're going to bring it back to the slides for some quick key takeaways. So let's get right into it. Azure RBAC is an authorization system. And what we're talking about as far as authorization systems is referring to a few components here. With authorization systems, the first component is defining the who that we want to authorize. And this could be a security principle like an Azure AD user or a group. And once we've defined who we want to authorize, we then get into the next component, which is defining what we want them to be authorized to do. And this is using a role definition, and then we make an assignment of that role definition to that identity so that we're providing them with capabilities to perform actions defined in this role. And the final component of the authorization system for Azure RBAC is the scope, where we're defining where we're going to authorize them to perform these actions. And when we're talking about Azure RBAC, also known as Azure roles. We're talking talking about providing identities, actions that they can perform on our Azure resources inside of things like our Azure subscriptions. And this is resources like virtual networks or storage accounts or virtual machines. Now, with Azure, what we have to understand with these identity objects inside of our Azure AD tenants is that by default, they're going to have an implicit deny, meaning that they can't perform any actions anywhere by default, because even though we have this trust relationship between our Azure AD tenants and our subscriptions that allows us to use these identities to perform actions on our Azure resources, we have to understand that we have to provide this access explicitly. And how we do this is by providing a role assignment which outlines actions that can be explicitly allowed. For example, setting a role assignment on this user and providing them access at the subscription level, which means they can access all of the resources inside of those subscription as well, such as a storage account here. But let's say in the example here we have that we want to deny access specifically to just this storage account. Well, that's where we provide an explicit deny, which overrules our explicit allow using a deny assignment. And this deny assignment will outline some denied actions for this user on the storage account. And so this user would have access to all of the resources inside of the subscription, except for the storage account where we've denied access. Which brings us into understanding role definitions here. As we can see, our role definition here in this JSON body for the contributor role definition, we have a series of different components to our role definitions. The first being our actions component, where we define what actions are allowed to be performed on the management plane. And when we're talking about the management plane, we're talking about managing resources inside of Azure, like stopping and starting virtual machines. machines. And then the next component is our not actions. And what we're talking about here with our not actions are the actions we're going to deny on managing resources inside of Azure. For example, if we wanted to allow a user to perform a restart on a virtual machine, we could outline that in actions, but it could be overwritten and overruled by a not action denying that same action inside this role definition. Then we have the next component, which are our data actions. And our not data actions, and these are the same kind of thing as our actions and not actions, except for rather than being on the control plane of managing Azure resources, this will take an impact on data related actions such as working with data inside of Azure storage accounts. Now that's outside the scope of this lesson. But it is important to understand the components of a role definition. Then the final component is an assignable scope, where we define where we're going to assign the scope for this resource, and it can be all the way down to a specific resource where we assign the scope to a resource group, to a subscription, or even a management group. Now, when it comes to understanding role definitions, we have to understand that what we're really looking at here is our actions minus our not actions, and understanding how these will provide us the collective permissions of this role definition. And it's the same thing for the data action and not data actions. It's just one is on the management plane and one is on the data plane. Now, this brings us into talking about additive properties, because sometimes we're going to have more than one role assigned to a user. For example, if we have this user here in our Azure Active Directory tenant, it is assigned the contributor role at the management group scope here, but also assigned a reader role at a resource group scope inside of the same hierarchical structure. What we have to understand when we have overlapping roles like this and multiple role assignments for a single identity is that roles follow an additive property. So what we do is we add the effective permissions of each of these role definitions. And by performing this addition, this will inform us what the effective permissions will be. So in this case, contributor plus reader equals contributor, because contributor provides reader functionality. So effectively, this user will have contributor at the management group scope, and that will be inherited all the way down, and there's no additional permissions that are being provided by actually having the reader role assignment. So this user's permissions
Tell me your story, Hide.
In Japan, had such number one steady head. One day, Yakuza boss need new head. I do operation, but mistake. Yakuza boss died. Yakuza very mad. I hide fishing boat. Come to America. No English, no food, no money. Daddy, give me job. Now I have house, American car, and new woman. Daddy, save life. My big secret. I kill Yakuza boss on purpose. I could search him. So best.
For hobbies, yoga, belly dancing, snake charming, beds of nails. I like
Whoa, 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 whoa. This is Hidetoshi Hasagawa. You would like to apply for the Sabre Minority Executive Training Program Print in All Colors Initiative.
Wait, what are you doing?
Helping heal America in a dramatic fashion in the 11th hour.
God, I hate you so much.
Caucasians. Am I right? Have a seat. I'll translate.
Why? I don't need translate.
You don't know what you need.
Well,
Just
why don't you tell me a little about yourself, Hide?
In Japan, how to search.
will just waterfall all the way down and be inherited to the lowest level. Now, this brings us into the demo component of this lesson here, where we're going to be assigning access to resources inside of Azure in a non-Azure Cloud Sandbox. The first thing we're going to do for this demo is get into a non-Azure Cloud Sandbox and select a user . So we're going to pick the who needs access to Azure resources. So we'll have a user, and then we're going to select a role that we're going to assign this user, which will define what permissions they have on this Azure resource. And then once we've determined who can do what, we're going to define where they can perform it by selecting the scope of the assignment for this role for this user that we've created inside of our demonstration. So let's make our way into the Azure portal in a non-Azure Cloud Sandbox environment so that we can get started. Alright gurus, here we are inside of the Azure portal in a non-Azure Cloud Sandbox environment. And to get us started for this demonstration, the first thing we need to understand is that we're trying to provide a user that we'll select here in just a moment a role assignment of a specific role, which will determine which role to use here in just a moment as well, at a specific scope. So first, let's understand where would we like this user to have access. And let's just say we want to set the scope to a resource group so that this user will have access with the role assignment at the scope of a resource group, meaning that it will have access to all those resources inside the resource group as well. So we'll just pick one here, one of our resource groups. I'm going to pick this My Resource Group. Minimize the blade here, and we see we have 10 resources inside of it. Now, when we provide this role assignment, we're going to be providing it at the resource group scope, so it'll be inherited all the way down to each of these individual resources. So if we click on Access Control here, and we come over to Roles, what we can take a look at is all the roles we have available, be those built-in or custom, if we had any custom roles in here, and we can determine which role assignment we want to provide. So maybe we want to make it so that this user can be a contributor, which means that they'll be granted full access to do all of the things that they want to do to the resource, but they won't be able to provide other users access as well. So we'll just select contributor here, and what we could do is then add a role assignment, and now we can choose which role we want to use. Contributor in this case, click Next, and now we can choose whether or not we want to assign access to a user group, service principal, or a managed identity. Now, we're going to use a user here, so we'll just select the user, and we're going to pick one of our users from the Azure Active Directory tenant. You could choose whichever one you want inside of your environment if you're following along inside of a personal or work environment. I'm going to choose this Chad Smith user here, click Select, and then I'm going to click Next. I'm going to see what's going to happen here. We're assigning the contributor role at the scope of this resource group to this user, Chad Smith. So we'll click Review and Assign here, and it's going to make this role assignment for us. So now, if we go to Role Assignments, we'll see here that Chad has the contributor role assignment at the scope of. Now, we're going to use a user here as well. So we'll just select contributor here, and what we could do is then add a role assignment, and now we can choose which role we want to use. Contributor in this case, click Next, and now we can choose whether or not we want to assign access to a user group, service principal, or a managed identity. Now, we're going to use a user here, so we'll just select the user, and we're going to pick one of our users from the Azure Active Directory tenant. You could choose these individual resources. So if we click on Access Control here, at the scope of a resource group, meaning that it will have access to all the. We'll just pick one here, one of our. When we provide this role assignment, this group in this case. Alright, gurus, we've connection systems that we use to provide identities with access to those Azure resources inside of our Azure cloud. Now, whether or not we're providing access to the resources for our Azure AD tenant, those identity resources like users, groups, and applications, or those Azure resources inside of our subscriptions, inside of things like resource groups where we have virtual machines and virtual networks, that will determine whether or not we use Azure AD roles or Azure RBAC roles. But in the grand scheme of things, it's all about providing resource groups where we have virtual machines and identity resources, really just off implicit deny. And then we have to Howdy and welcome, gurus. I'm going to make a role is that slightly so that it meets our needs, and then we're able to create a new custom role for our purposes of providing access as we intend to do in our actual machine. Understand, meet the requirements for what we're trying to do. Now, the components that go into creating a role definition are first that we understand for the custom role that we're creating level for to a user that we're trying to has a name, and this name is held compute not actions be and now we need to provide our this access role definition create, click add a group, and understand definable scope for that role. Will be allowed to create a custom role definition. Now, I want you to understand that whenever you're making a custom role, you have to have Howdy and welcome, gurus. I'm Chase, one of your Azure training architects here at ACG, a Pluralsight company. And it's in this lesson, understanding storage accounts, that we're first going to start off.
By programming languages, I mean, at the end of the day, you're just reading code, but like, the hidden performance cost, I forgot that word existed, of Node.js and GraphQL. Okay, so Node.js and GraphQL are popular technologies for building web applications, but in my experience, they come at a certain scaling and performance trade-offs to be aware of. I thought Bun made JavaScript faster than Rust. So what's this thing he's talking about? Incorrect take? Bad take? GraphQL's modular structure generally leads to code that instantiates excessive promises, which degrades request performance. Benchmarks show as much as 2 to 3x latency increase. Yeah. Yes. About 3 weeks ago, I tweeted that promises are actually really bad for performance. Okay, Node.js is known for its non-blocking I/O operations. Yeah, that's what everyone keeps telling me. If you say something like this to the modern JavaScript engineer, if you say the phrase, "Don't use a promise," you will literally get people to be like, "You mean you're going to write sync code? Isn't that slower?" And it's just shocking that there's not a middle ground like, "Oh, you mean you want me to handle this without using, you want me to do async without promises?" It doesn't exist in the brain at this point. It's shocking. All right, all synchronous work in Node.js happens over an event loop thread. Other than a few isolated multi-threaded features like worker threads, and of course garbage collection largely happens async. If you read the, what is it, Oriocho? What's the name of it? Oriocho? Something ORO, something is the name of their... sweet garbage collector. It's awesome. With the event loop is managed well, and the I/O is a true bottleneck. Node.js can be very efficient / scalable technology. A few promises and going back through the event loop can actually really help. People forget about continuation passing style. People forgot about I know, it's handlers. That overlay consume, it's really that simple. But if your instance runs on a single core, you get massively hampered by garbage collection. Right? A garbage collection is so efficient these days because it can run on more than one thread. Additional, GraphQL's resolver structure can result in more promises overhead compared to REST endpoints, which may cause suboptimal user perceived latency if not managed carefully. Fair. GraphQL, oh no, it's that thing. Here, continue reading. Just let a man read. GraphQL enables a modular design for APIs. For example, we define a type in our schema and define the one resolver for that type, regardless of where that resolver appears in the graph. User, query the user. This modular design is great for developer experience, but leads to promise-heavy code. Okay, yes, we know. Each promise adds a minuscule but non-zero amount of work for the event loop, which is discussed here. To demonstrate, let's say we want to write a feature that retrieves a user's item. Let's see, that retrieves a user's items. Wow, so many S's right there. On a shopping site, we might build a REST endpoint like this: user items details. This would be powered by a few squeal queries. Get some user, get this. You know, typically, maybe we would do a join. You know, I always say we should just write squeal instead of using an ORM. I might be mistaken. A well-structured REST endpoint would have some relatively simple code that makes these database queries and massages the data back into a desired format. We would have no more than a few promises involved and resolve in the request lifecycle. In GraphQL, it's where you start making a bunch of small requests to something else. And so chatty protocols tend to have like a distributive degrading performance query problem. This would translate to the same squeal queries as we described in REST endpoint case. So the I/O cost would be as optimized as possible, but we would create one promise per item in the loop, and each promise adds work to the event loop. A promise per field is pretty crazy. The overhead increases as we increase the number of promises involved. We choose 2 GraphQL servers, Apollo Server Plus Express and a Mercurial. Instead of putting select before front, performance that has been larger. Right, will reduce significantly as a percentage of time taken by the resolver. A well-tuned database can perform 2 squeal queries to return 10K items in less than 100 milliseconds, which is I mean, all of this doesn't make any sense. Like, so you get, you know, it can be bad. It's a loop, if one would say. Now, what does the task queue look like? Well, every time you do something like set timeout, what will happen is that there's a linked list that exists somewhere. And every time there's a set timeout, it does this. Transactions stay open too. Yep, it's going to stay open for a while. So if you use like a callback to write a file to disk, or you use a promise, what you get is when the thing is done, right? When writing a file is done, it calls the callback. That callback is called synchronously, right? So it stays. You maintain owning the process event loop for the duration of that callback. So you do your extra work, going to the back of this queue. I'm sorry. Even though we were making an index query, JavaScript do not prevent developers from unnecessary marking functions as async. Yes, this is true. So we need source pooling. No, they don't do any of that because it's not. What's that, TJ? I mean, I would say we're probably in cancel territory. Boom. Okay, so you create an object and an array, and you create a closure, and you create a Lambda function. Okay, you create 4 pieces of things that have to be cleaned up.
In this video, I'm going to explain all the core technologies you need.
Welcome to the Career Latte podcast.
The Career Latte podcast is a must watch because I think this is when you're going to get a lot of industry insights from various people, professionals, and
to share. The same time when you pronounce it as latte, this is actually something you and I will order when we go out to cafes on it.
I'm very excited to younger generations to connect along, hoping here
how the you are able to enter.
Given faith as well as
getting information.
You started at SIT. Have you made friends and become a...
We are all so proud of what you have accomplished. I believe your journey at SIT, while challenging, has brought you great fulfillment. As you cross this remarkable milestone, you are embarking on an exciting new life chapter. You are now ready to meet the world. Stay connected with SIT and keep sharing your remarkable life.
Dear students, or should I rather say, dear engineers, for the past 3 years at SIT you have been acquiring technical knowledge, industry-relevant skills, and also many personally enriching experiences. Your hard work and dedication is sentiment. Congratulations on your great achievement.
Congratulations. I'm so proud of...
By the ceremony near the front seat. After graduation,
This is, in a sense, what I call one of our highest aspirations or holy grail. In terms of trying, we are now shift. How do I differentiate myself?
One of Timus's local practice. So thank you so much to all of you for the opportunity.
Very, very quickly, almost immediately after
Congratulations, job well done to Run Out System developer.
This was an amazing experience, both for me and for them. From the beginning until now, they went a long way. You're ready to start working with OutSystems.
For sure. Be proud of your accomplishments. Be excited. Keep up the happiness that you showed all through the training program. It will serve you well when you're working on.
Really excited as I am. Learning OutSystem, learning about databases, API, DT.
Hope that it has prepared.
I think we can get much more precise on predicting
also wish you could say goodbye to never set your schedule seamlessly within tasks, such as their chart status.
As a densely populated country, collapsed buildings pose an evident threat to our lives. Rescuers must adhere to the United Nations INSARAG protocol before searching for casualties, which result in delays and thus lower survival rate. Victim detection devices are employed into voids. that are inaccessible to rescue personnel, to seek for survivors. The objective is to design and develop a flexible equipment that is operated by pneumatic to detect for victims. The interior
and outputs of language models.
I'm excited to share with you this new short course on LangChain for LLM, Large Language Model Application Development. This is built in collaboration with Harrison Chase, creator of LangChain. LLMs have made it possible to use prompting to develop powerful AI applications much faster than ever before. But an application, say building a question answering system to answer questions about the text document, that might require prompting an LLM multiple times with multiple inputs, pausing the LLM output to then feed it to downstream LLM prompts, and so on. And so there's a lot of glue code needed to build these applications. LangChain, created by Harrison, is a powerful open source software package that mixes processing
applications with language models. It started after I had a bunch of conversations with folks who were building cutting-edge prompts and parsers when calling a language model computation. With these built
to put the application together, community of open source development.
Today, I want to talk about a real AI research agent. If you remember, in one of my previous videos, I talked about this AI use case where Michael mentioned, what if I can ask ChatGPT to write a Twitter thread every other day about how a famous people get rich and automatically publish it, and you can get 100k followers in just 1 year. And this was a prime use case for GPT. And in the first version, I used a LangChain to create a linear AI workflow where I will give a topic and it will go search online, get a list of your decision engine, finish this task, or should I continue going? That's why I think there are huge opportunities. Agents that is how likely they are going to purchase this product, and then putting all those information into Google Sheets or Airtable as a prioritized list. And when you expand it with what Make.com is, it is basically an integration platform that started. We'll firstly set up a research agent via LangChain in Visual Studio Code. Next, we'll create a search tool for agent to go on internet, grab useful links. And payload that we defined above, and this put in. Next is we will create a custom tool for scripting the website. Can only take up to 16,000 tokens. And to handle the token limit of large language model, there are mainly two ways. One is called MapReduce, which is model with GPT 3.5 Turbo 16K version, and then we will use text splitter. This will break down a 40-page content into that if the length of the text is really big, more than just quick recap, you will define that we just defined here. And you will notice that format for the agent. And then I'll create a memory variable so the agent and return a list of links. And then it starts scraping website for relevant articles. Alright, so within 30 seconds, it search across website and give me these results. The Meta's new product threads grow very fast because of instant credibility and integration with Instagram. They grab all the information available across multiple different links from LinkedIn to. We will create a new class called query, use API endpoint, pass on this JSON format query what's Meta's new product threads. So I will create a new terminal by clicking this plus button, and inside I will run Python testserver.py. Alright, great. You can see it returns the results, but looks like there are a lot more stuff than we need because it includes the inputs, memory, a bunch of other stuff. And what we actually need is the output. So I will go back and change the API endpoint here, so we will return say actual port 10,000, and then we'll choose free. Before you move on, also click on this advanced button and add a few environment variables. We will need to define the Python version 3.11.2, which is the latest one, and then you will also add the API key that we defined in the .env file into here. And once you did that, you can scroll down and click create web service button. It will take a while to deploy, but once it is done, you should see a message here, your service is live. Okay, and let's test it out. We can copy this link here and move back to the testserver.py and replace the URL to be this hosted web service, and we can try to run this. And as you're running it, you should be able to see some message on the log as well. So you can see in the log it returns. That's it. You can see the Google account has been set up properly. And then the next step is use OpenAI as the way to extract the name and company info from this email. So I will add this step with OpenAI. I will use the chat completion methods and use the GPT 3.5 Turbo June 13 model. And I will add a few messages. Firstly, I will give a system prompt. You will help me extract information from email about who sent the email and their company and format it in a certain way. Person name at the company name, like Bob Wong at BoConcept. And then I will add this